Hello and welcome everyone to our second webinar. My name is Sébastien Vermeulen and I'm with my colleague Billy De Keyser. I'm product manager in France and Billy is business development manager in US. We are Sarasin's representative, the pressure relief valve line at Trillium Flow Technologies. Thanks to join us and take time on your busy schedule today. Billy and I are excited today to introduce our pilot-operated pressure relief valve, but the most advanced technical solution currently installed on FPSO, a product developed by our engineering to meet this both specification. First, reach the highest pressure, highest capacity, and second, meet the zero leakage, zero defect, which was our customer ultimate target for this job. So let me introduce the topic that will be covered today. First, we will start with an introduction to get a baseline knowledge for everybody on the call to know more about what we are doing. We will detail some operating condition on FPSO application to understand valve selection criteria. Additionally, based on our customer valuable comments, we propose here to give you a quick overview of API and ASME so that you will understand some fundamentals. API and ASME, it's huge, so it could be part of a separate webinar. We can spend 1 hour to explain the different webinar, but during this presentation, we just propose to introduce the basics, some basic. And then we will talk about the technical feature of our pilot-operated pressure relief valve and value before answering your question in the Q&A session. So if you can submit questions, have that come up in the Q&A box, we will reply at the end. Throughout today's presentation, there will be QR code available, as you can see on the screen. Don't hesitate to scan and learn more about our content, either on webpage, LinkedIn, or YouTube. As usual, remember to keep the presentation in full screen mode if possible to see data presented in graph, in table, and video, because today many video will be introduced. First, let's start with a brief history of both brand, Sarasin and CBIM. All these dates are important, but let's be focused on the essential one. So to be brief, in 1956, Sarasin developed a range of spring-loaded pressure relief valves which comply with the essential American technical standard intended for the oil industry. It is really important for us because at this time, Sarasin's first 2 customers were Shell France and Total. So it was a good start. In the second important date is in 1983, because the brand has been sold to the US company Anderson Winwood. At this time, Sarasin takes the opportunity to diversify its product portfolio, manufacturing ATCO pilot-operated pressure relief valve, so ATCO Anderson Winwood Crosby, for the French market. And the last important date is in 2019, because we have been sold and create a new company with the name is Trillium Flow Technologies. And today we are able to address a complete portfolio with valve, pump, and service solution. 2 other important dates in this timeline in connection now with CBIM. So CBIM is a nuclear brand. CBIM started its mission providing safety device for the nuclear market in 1978. And CBIM also buy Sarasin in 1998, as you can see. So at this time, from 1998, Sarasin and CBIM are registered under the same legal entity in France, and we share some technology. Few words about what we do, just to give you a brief idea. What did we do during this 170-year plus experience, and what do we continue to do today? Basically, we manufacture product devices that tend to ensure safety function. These devices are the last safety line that protect people's life and equipment. Basically, whatever the product line, each of our products meet safety function. Safety function can be summarized into two parameters, two functions. The first is to be open at set pressure. So set pressure is a technical wording which is specifically used for safety pressure valve. And the second is to discharge a certified capacity. These two functions, be open at set point and discharge a certified capacity, is true whatever the product line, spring-loaded or pilot-operated type. Now, depending on your process and applicable market, we can select either pilot or spring-loaded in our product portfolio. Today, Sarasin addresses three major markets: power industry, nuclear industry under the SEBIM brand, and oil and gas industry, including FPSO application, the market for which we developed the special valve that will be introduced today. In the teaser, you have probably been interested by the fact we mentioned the technology introduced today has been adopted by the nuclear industry. That's true, and you can see here a cross-section of the most advanced pilot developed by SEBIM. Why nuclear activity is so special, is so unique? Because it's required a high level of qualification to withstand several accidental scenarios. As an example, for instance, LOCA. LOCA means loss of coolant accident. In this scenario, a safety valve works as a control valve to relieve and cool down the reactor in accidental condition. In this scenario, you have to consider irradiation, seismic condition, and you test the valve in a laboratory under pressure. So the qualification process is very long, as you can imagine. And on the top of that, everything is under the supervision of the French Nuclear Safety Authority, what we call the ASME. So that makes, when a product is certified, it is first well recognized, and that definitely ensures safety function. Today, this product is installed as a strong reference list, a strong install base, because it is installed in more than 163 nuclear units worldwide, 58 units in France, 46 in China, and 26 in Russia and Ukraine. So this product also plays a significant role in extending the life of the existing power plant beyond the 40-year that was the initial target. So due to the pilot integrity, we managed to extend the power plant lifespan. It is really interesting when you consider the same feature today used in our pilot operated pressure valve. So I'm just spoiling a little bit my presentation, but it is important to note here the comparison, as you can find the drill connection and the pressure feed through that has been marked in blue in this presentation. So now get back to the initial application we want to be focused today, the FPSO application. So let's look at the FPSO application. For those unfamiliar with this term, FPSO means floating production, storage, and offloading. Today, it's become the most common type of offshore production unit in the oil and gas industry. Basically, the FPSO is built in a tank-based hull and topside processing module located on the upper deck of the vessel. The function of this module is to clean up the impurity associated with the extraction process. Because if you have hydrocarbon, you also have produced water, acid gas, nitrogen, salt, and sand. So everything has to be clean. And as you can see, in these different modules, our pressure valves are pretty much everywhere at different pressure and temperature. So today we are going to be focused on the valve that has to withstand the highest pressure, the highest capacity. And as you can see in green, these valves are located in the main gas compression module and the export injection gas compression module, so the module 3 and 4. As you can imagine, it's about a custom-made design, and pressure limits go well beyond the API standard pressure limits. So before getting into detail, and because we have many discussions with EPC, our main customer, who are questioning about this, I will pass on Billy. He is pleased to explain you today the respective function of API and ASME in the oil and gas industry. Sorry, just I missed this point, but I also introduced the same value in PSI for people who are joining us in US. So as you can see, the pressure is very close to 10,000 PSI for those who are unfamiliar with the metric units.
Oh, thank you, Sebastian. Good morning, everyone. When it comes to sizing and selecting relief valves, do I use API or do I use the ASME equation? Well, API is the American Petroleum Institute. ASME means American Society of Mechanical Engineers. So do we consider one or do we consider both? So what is the difference? Well, I'm going to explain that to you. API is mainly for the oil and gas market and largely used by EPC companies when they're sizing and selecting relief valves for whatever unit they're building. So it's not the law. API is just guidelines for the customer or engineers to use. So as per this guideline, say a customer asks for clarification whenever his API pressure limits are exceeded. And we see this question asked a lot in the marketplace. So according to our table, it shows that a 6Q8 max set pressure is 600 pounds. So this is what we're going to try to explain to you. So let me remind you of the fundamental. In this example, API pressure limits is from two parameters, whichever is lower. First, you have the maximum inlet flange pressure values that are from ASME B1634. The second parameter is going to be the spring force. The API standard 526 ratings are limited by the size of the spring. So that's what you see represented by the value there in parentheses. So now you take the same valve as per ASME B1634 pressure limits and temperature, 600-pound class, is able to withstand up to 1440 psig at 100 degrees Fahrenheit. So it is far above whatever the process conditions that were required by the customer. So in this example, we have the confirmation that the spring-loaded valve is limited by its spring due to its orifice size, which is a 6x8 cube. So for the piping engineer, when he's sizing and selecting, this issue often occurs, and due to spring-loaded pressure limits, he has to go up to a larger size. So another parameters could be the outlet pressure limits that would naturally limit the orifice size. It would be another reason to adopt the block forge design, as on that case, we have to select the next upper outlet class. And remember, even on the ASME, we still follow the API 526 table. We never lose our inlet and outlet connections as far as the center line dimension is concerned. So according to that application case, it's up to the valve manufacturer to contact the spring manufacturer and develop a new model. So in our case, if you look at NV cert number is 92001. So we can exceed the pressure limitations of API. And as you see in the bottom graph, we can go from 15 to 1000 PSI on air or steam. So we simply explain our PSV was suitable for that application. But our PRV will continue to meet, like I said, center line dimensions of the API standard 526. However, the API pressure limitations will be exceeded. So API standard 526 was designed so that every manufacturer size is selected using the same orifice area and the same centerline dimensions. And by doing this, the customer has the option, if he wants to replace a competitor's valve with a Sarasin valve, they'll fit right back in the same piping configuration. API only has 14 orifice areas that are designated, D through T orifice. And as you can see, the orifice area in the chart, these are actually the theoretical orifice areas, not the actual. ASME gives you the actual orifice area of that valve. So if you look at the valve sizing, rating, inlet, and outlet in this chart, the 4N6 only goes up to a 900-pound inlet pressure class with a 150-pound outlet. The center face dimensions are identically the same. They don't change. So we have no problem there. But your material requirements has associated pressure and temperature limitations. So basically, if you look at these two tables, the table on the top is spring loaded, the table on the bottom is the pilot operated relief valve. And as you can see, they highly exceed the API limitations. If you look at the pilot valve, the 900-pound valve can operate up to 2220 psig. The 1500 is available only in the pilot operated valve, and it goes up to 3705. So that is one reason why we are offering a pilot operated valve solution. Now, if you look at ASME, we consider this the law. We have to follow every rule and regulation that ASME puts down on us in the Section 8 class. So we have to have the set pressure, and we have to have a certified value. If you see where the arrow is pointing, our certified value in this case would be 0.848. Our media, our test that it can operate on, it was tested on air and gas, but it's certified air, gas, and steam. So all this is available in what we call the Red Book or the NB18. The NB18 changes every month, every week. It could be every day sometimes. There's changes for different manufacturers. So you'd have to go to NB18 to certify what you're looking for. And the nameplate instruction, everything about the nameplate has to follow ASME. They have their own guidelines. So now, if you look at the orifice designation and the certified area, you see the flow area 0.124 inches. Then the designated area is 0.394 on an inch and a half on a 1 by 1.5 valve. Now, if you go down to the bottom where we have the different sizes, we can go, if you have a 1 inch and a half by 2, 26 to 4,350 psi on air, on steam, excuse me. And on air, it can go all the way up to 6,250. And if you go down to the 2 by 3s, we can go all the way up to 10,000 pounds on air or steam. But we want to make sure that we have the valve capability to relieve the required capacity with the right orifice size. So we have to be as close to our process and have the right ratio, orifice to capacity, which help prevent the chattering problem that you sometimes have with oversized valves. Now, what about Section 8? So it is important to note that our cert can be updated provided that engineering provides and demonstrates the orifice can reach that higher pressure. So we have to, anytime we make a change like this, it would have to be going through the national board, and they would certify us for this higher pressures to exceed the API 526, because you are limited in terms of material for pressure and temperature limits. So ASME provides a list of approved material, which is much more important. A list of material that we have to follow before we can apply the UV stamp. This list is a restrictive list, and some materials like casted nickel alloys are very limited. So that's another reason to justify that we have to adopt to a forged version as well.
Thanks, Vinny. So Just to support our global understanding about API and its impact in terms of valve selection, let's take a look on this application case. So this scenario is based on an existing customer inquiry where the end user must protect its production heater. The issue, if we can say that, is coming from the combination of these both parameters. I mean, the combination of the high pressure, 145 bar, almost 10,000 psi, and a high capacity, almost more than 600,000 kilograms per hour. In this graph, it is represented certain pressure limits for different size. So as mentioned by Billy before, in API, we have 14 orifice size. However, in this graph, we make the choice to represent only 7 of them, just to have something representative, a representative picture of the API pressure limit. So we go from orifice D for T, and as you can see, the pressure is limited. So the blue line is for API standard spring-loaded table. The green line is for API standard 526 pilot operated table. Let's be clear here. It's not Sarasin pressure limits. It's the same pressure limit you will find if you take a look on the API standard 526. So we just represent the value from API. Of course, select the next upper orifice means you will have some additional material stress. So that's explain why the larger the orifice we select, the lower the pressure we can expect. It's especially true for spring type because, as explained by Billy, the spring is also limited due to the bonnet volume chamber. So in gray, we identify orifices that cannot be selected due to the pressure limit. So just let me summarize. In this graph, we can see key orifice, spring-loaded type, and P orifice, pilot operated type, are the biggest size we can select based on API standard 526. Because naturally, due to the pilot body wall thickness, a pilot can always withstand higher pressure. Unfortunately, on that case, customer asked to keep spring-loaded table, spring-loaded valve. So now it's up to customer to follow API standard 526 guideline, and a solution exists. We can see that. However, due to the small section area, there is 2 issues. The first is customer has to adapt its pipeline to fit 7 valve 3 key 6, because yes, the orifice is limited, so you need a significant amount of valves to relieve the total capacity. On that case, you need 7 casted version API standard 526 3 key 6. So the second issue is coming. I mean, it's a term of safety, because it is recognized the higher the number of parts or valve, whatever, the higher the risk of failure. Any failure mode analysis will have the same conclusion. If you want to reduce the risk of failure, you have to reduce the number of parts. One additional part makes you increase your risk of failure. That's the way any failure mode analysis works. So on that case, we all agree there is some room of improvement in terms of valve selection. And we propose alternative option to customer based on forge block. So on that case, again, customer insists to keep a spring-loaded configuration because spring-loaded and pilot-operated has both benefits, have both separate benefits. Spring-loaded is recognized for its robust design and large chemical compatibility. So on that case, spring-loaded was required, and customer was not limited in terms of weight and height. So we adopt spring type. But we adopt spring type for 3 different configurations, as you can see in this graph. So as a reminder, I keep the key orifice, the initial selection based on API regulation. And I had in green our 3 proposal, 3 block forge. So as you can see, the block forge pressure limit is significantly higher because you can adapt the bonnet and select biggest spring size. You don't see clearly in the picture, but if you look, if you look at the spring here, you can see we don't have only one spring, but we have two springs. There is another one inside the initial one. So we reinforce the spring to withstand higher pressure. So on that case, the proposal was as follows: 3 MRFIs or 2 PRFIs or 1 single purifies, what you see in the picture. Most of the time, customer is concerned about the block forge cost. And I take the opportunity today to discuss about this application case and draw your attention on the selection mode. So please keep in mind, a valve selection is done based on the set pressure value and the global capacity for a unique scenario. Of course, there are other parameters to consider. Operating pressure, back pressure, we'll discuss just after. But let's try to make it simple. Let's be focused on the cost approach. It will not be fair to compare a cast version with a forged version. And if you want to compare apple to apple, it's more realistic to compare like this. How a valve manufacturer is able to adapt solution to meet a unique and global accidental case. So on that case, the cost saving is significant, because if customer decide to select block forge and adopt one of the 3 solutions we have on the screen, the cost saving will be 25% if you go for the 3 MRFIs, 38% if you adopt the PRFIs combination, and 60% if you decide to go for 1 single QRFI. So 60% cost saving compared with the initial casted version. That's the approach you should adopt considering a cost analysis. Forged solution is costly, but because of the amount of valve, at the end of the demonstration, it is the cheapest solution. And above all, the safety function is optimized. In parallel of that, keep in mind you reduce the maintenance cost and also the spare parts, because spare parts are reduced. It is what we call the upgrade level 1. And for some reason, as discussed earlier, spring lead and pilot combine each other, and we may propose the upgrade level 2. It was not the case here, but for some reason we can adopt pilot operated valve because you have high operating pressure, or you have to withstand high back pressure. Because due to the design, due to the internal design of pilot is not affected by back pressure. Pilot is rarely a choice, but it is a mandatory requirement when you have to consider such kind of parameter. So high seat tightness, significant pressure loss. So that's the reality. But we already discussed about the benefits of pilot operated modulating action in our previous webinar. So as a reminder, I put a QR code here, and I do encourage you to, to scan it, to learn more about our product. So as you can see here again, one of the main drawbacks of pilot operated valve is about its robustness, because as you can see on the screen, we have some piping, and piping is brittle. So it is a drawback. Let's be fair, it is a drawback. But how we can solve this issue and make our pilot sexier? Because customer is concerned about that, and engineering work on it to develop a new kind of technology. And I will pass on Billy that will explain you in detail, but more in detail, or introduce our ultimate solution developed for the FPSO application.
What our engineering firm came up with for this solution is what we call our blocked forge solution for the FPSO market. And as you can see with the valve turning in the video, there is no tubing there. But customers had questions. There's 3 things they wanted from a valve. They wanted valve efficiency, they didn't want any leaks, and they did not want any defects. So that is the reason why this valve was designed. As we all know, a pilot operated valve can have very narrow operating conditions. A pilot operated valve can operate at 98% of the set pressure without any valve leakage whatsoever. And why you can do that is because if you look at the internal valve as it goes around, the area on top of that dome up there where the dome line feeds in is 30% larger than the seat surface area. So pressure times area equal force. So the closer it gets to set point, the higher the force is pushing the disc closed. So that's the reason why it can operate at 98% of set pressure. But at the same time, they didn't want to have any leaks or any defects with the valve whatsoever. Because the old pilot valve, as we saw in the last screen, has piping everywhere on the outside. And because of all the piping connections, the pilot operated type was not considered as a favorite solution until we designed this valve right here. But today the piping is replaced by drill connection. Now we say no tubing, and I know everybody sees that little yellow piece of tubing on the outside. That is when you have to run the exhaust to the valve body to where you do not have any greenhouse gas emissions or anything going to the atmosphere. Everything is contained within the body of the valve. So throughout the presentation, you will see icons to help you identify the features that help resolve these three concerns. You want to keep valve efficiency and high level process. You don't want to have any leaks. You don't want to have any defects whatsoever. So on the next slide, I'm going to show you how it works. As you can see, that we're the only manufacturer that runs 3 pieces of tubing to their pilot. And the reason why, if you notice the green line coming there, what that does is that you have the same system pressure inside the valve, inside the pilot at the piston area. When the valve opens, it secures that piston from moving, and it stabilizes to eliminate any chatter within the valve. Now, you have one line is going to be your feed line. Another line is going to feed the dome on side. So the pressure has to come up through the inlet of the valve and go through the inside of the main body where it's pre-drilled, and this allows the pressure to get to where it needs to be. And if you can look at the old design on the right-hand side, these pieces of tubing were a lot of times used as a ladder. I mean, technicians or operators would grab them and use to hold on, and that, it's a leak path. So we had to eliminate or minimize the much product loss as we could, and that's where this valve comes in. So if you take the blue line and the red line, there was just what I said, control and the feeding lines. So they have a dynamic pressure in these lines that alternately pressurizes or depressurizes the main valve dome in response to the system pressure. And there again, that one little piece of yellow tubing is the only thing that's on the outside of the valve. And if it can be vented to the atmosphere, well, then you wouldn't have any tubing there whatsoever. It just would vent on the bottom of the pilot. So why a forged housing design and not a casted? Number one, what is a forging? Forging is metal shaped by plastic deformation under great pressure into strength components. Where if you use a casted, it is metal that's cast out of a pattern. So let's look at the weakness of the forging first. Number one, the valve will be 2 to 3 times heavier than the same casted valve. The machining operations will be longer, so your lead time is longer. Your casting enables creation of a smooth flow path and produces near net shape. So where could they both compete in an application? Well, the specific casting could be heat treated to improve the yield strength. Forging can be made out of a cast block. The composition won't be reworked if the health of the original pattern is affected. The block material composition will be affected also. So what are the current benefits of forging? Volumetric control, definitely easier, and the inspection is reduced. The ductility and capability to absorb the mechanical overload is greater, so it's very well suited for high pressure valves. Structure and density are better because on casting, as you can see in the picture on the slide, potential defects are higher with a risk of shrinkage, porosity, cracks, hot tears, or cold shuts. Delivery time is a huge advantage that sometimes justify the use of forged when it's not required on a technical standpoint. So there's no inlet or outlet pressures. But if you look at the slides, go back one please.
Oh, sorry.
I'm just showing the pictures where you can compare the forging that's on the right and the cast on the left. You see the difference. So what does that equate to? What about a value? Well, let's just talk values for a minute. A barrel of oil is defined as 42 US gallons or about 159 liters. Crude oil price is about 71 euros or 71 US dollars per gallon. An FPSO has the capacity of 220,000 gross barrels of oil per day. And that equates to $15 million in a day's time. So, of course, it's not profit, but a turnover generated by the FPSO. So, but that's the gross profit for the day. So in the oil industry, most of the time, the pressure relief valves aren't ordered until the project is almost complete. And without the pressure relief valves, they cannot start up. They have to have them in place. So that explains why the forged block are sometimes ordered as a response to a lead time issue. This gives us an idea of the valve failure impacts in terms of profitability. So it's up to the customer if he wants to decide to go with a forging or a casting. They have to make that decision. But you're going to have extensive NDE requirement. You got to have microstructure examination and also the ferrite contents in the body. But
Okay.
having the forged version, it helps to reduce the risk of failure and optimizes your integrity.
Thanks, Billy. That's clear. That's clear now. Delivery time will be shorter for forged block compared to casted version where you have to add a lot of NDE testing. So that's the reality in our business, and that's the feedback we have. Thank you. So we propose now you have a clear understanding of the reason why we propose the forged block. Let's review in detail the technical feature that has been adapted in this pilot operated valve. So first, let's start with the same technical feature I introduced at the beginning of this webinar for the nuclear application. I'm talking about the pressure feed-through component. In these valves, pressure feed-through components serve a critical function because, as you can imagine, they ensure the continuity in line. So in case of failure, you will have some leakage issue, and that's the reason we brought special attention of this feed-through component. They have been custom made, and contrary to the nuclear market, that have been upgraded because these valves work at a very high pressure, higher than in nuclear, 10,000 psi, and that's the reason here we had additional backup ring to optimize the tightness between the separate block. So all these parameters has been put in place, of course, to reach our zero leakage target here. We will note also if we can adopt some pressure feed-through, we can also adopt pressure plug, and it will be introduced by Billy at the end of this webinar. But plug also help us to redirect the line, and because it ensures the line termination. But redirecting the line differently, it will be very helpful for accessory integration as a retrofit, but it will be just discussed later. The third technical feature is also part of our zero leakage target and the part of the zero leakage requirement, because we have special attention has been paid to the forged block fastener, as you can see. The same story than the nuclear market. We take into account any parameter that will make forged block disconnect. So here, through the involvement of our closed network of sub-supplier, we create a sub-supplier to create an innovative bolting solution to hold the functional block in place. It's about what we call wedge locking technology that secure bolted joint, even when exposed to severe vibration and dynamic load. Bolted joints are here secure with tension instead of friction. So that's a new technology to optimize the tightness. On that case, it's simply impossible for a functional block to be disconnected unintentionally due to the wedge created underneath the bolt head and nuts. So that was the second technology. Let's talk about now the third one. Third one is very interesting because it's about it's localized into the pilot itself, as you can see. Sometimes when you drill connection, you have some issue to make them match or to connect to connect them together. So we have to use a separate process, what we call electrical discharge machining, EDM. It's a hole drilling process which is here used to connect the sensing head and the block inlet. Few words about this technology. As you can see, there is a spark generated for the high pressure dielectric fluid and the copper electrode that will machine high integrity material, in our case, duplex stainless steel, and that will allow to draw hole with an extreme precision at a specific angle and depth, so that the two ends of the sensing line will be aligned. So considering the sensing line in green, I just anticipate a few questions because you can say, okay, but in this graphic, finally, the section area is lower and you may have some issue regarding pressure drop. I don't know. But as a reminder, in the sensing line, the green line, here it's a static pressure. So it's not a big issue. So the challenge was, as usual, to optimize forged block structure and help to optimize the valve integrity. The last one we would like to introduce, there is many other technical features. We prefer to keep some of them secret, but we decide to introduce some of them. So this is the last one here. As you can imagine, our pilots work at a very high pressure. When you have high pressure, you have significant stress, significant stress. So you have to adapt your surface area to minimize this stress. So the design has been adapted accordingly. In the pilot also, it's the same. Pilot is industrialized in Sarasin. We always talk about DCS or DCSM for modulating action pilot. But on that case, the pilot internal component has been upgraded to withstand very high pressure. So this is a very high pressure version of our pilot. The critical drain spindle here has a critical function because this special part allows the pilot to snap at different position. So let me show you into the screen now, but I'm talking about this part, this is the spindle here. And here in green, you have the sensing line. So as you can see, the volume of the sensing line is really reduced. The valve is able to operate in a very short pressure room to make the main valve balance at to make the valve balance. So this drain spindle will either vent or supply pressure to the main valve dome, staggering main valve position and lift based on the system required capacity. Again, I do encourage you to watch on our YouTube page the previous webinar because we go in detail regarding the modulating actions. So it could be interesting if you miss some information here. But on that case, the target was to reach, of course, to reduce process loss, but also to ensure very fast response time and optimize modulation. So this pilot, it was not initially expected, but this pilot operates in a very short time and is really, the response time is very significant. So why do we put in place such kind of technology, and why it was so important for us? Because in Sarasin, we enjoy to develop custom-made solution, and we don't try to save cost in this pilot because first, the number of valves is reduced. So at the end of the day, it has been demonstrated the solution is cheaper. But it's like, for us, safety valve is the last barrier that protects people and equipment. And it has to be considered as an insurance warranty. As per public information, FPSO price is from 1-2 billion dollars, sorry. I'm a French guy, so I'm talking in euro, but here we are talking in dollars. So sorry about that. But compared to the capital expenditure, it means our safety valve package is roughly estimated at 0.1%. I would say it's nothing. Of course, it's a significant amount, but it's nothing compared to the equipment you have to protect. So there is a price to buy, but there is also some higher costs, what we call the price to repair. Because in FPSO, as you can imagine, FPSO operates in extreme condition, and it can be tough to identify troubleshooting. The man-hour cost on that case can appear prohibitive, and based on some previous root cause of failure analysis we have in hand, the average valve repair would be estimated, whatever the orifice size, more or less $70,000 per valve. Because this amount has been established based on the fact you have first to remove the valve from the FPSO, to ship the valve into the ground, to contact inspection, to contact our engineering, to perform valve repair before reinstalling the valve on site. So the process will be long. During that time, you can lose money if you don't have any replacement valve. So this price is without considering the profitability drop. And because the same cause usually occur on a set of valves with the same failure, it's never occur on one single valve. So if you assume such kind of troubleshooting occur on something like 20 plus valve, you already exceed the initial price to buy. So keep in mind, such hidden costs can be prohibitive. And that's the reason we developed some solution without looking at the hand costs. So another topic I would like to discuss before concluding this presentation, before end of the presentation, it's about the accessories. Because when we talk about forge, some customer may think about the fact it will be complicated for us to integrate additional accessories after that. The retrofit doesn't exist on forge block. And I will pass on Billy here that will explain in detail what kind of accessories has been put in place in this valve.
One of the most important accessories is what we call the backflow preventer. Now, just in everyday market, the pilot valve could always withstand more back pressure than a spring-loaded valve could. So what we had to do, if you look at the valve on the right, that backflow preventer is an add-on connection. And the reason why you have a backflow preventer is because you have what we call superimposed back pressure, where you have more than one pipe going to the same flare header. So that pressure gets in the line and comes back toward the discharge side of the pilot valve. So that's where the backflow preventer comes in. And in the old style, what you see on the right, this was an add-on component. If the customer ordered the valve without a backflow preventer, then he realized he had to have it. Well, then somebody had to come get the valve or install the backflow preventer in the unit whenever they bring the unit down. So basically, what we've done is reduce the parts and improve the main valve integrity. So instead of having an external backflow preventer, the backflow preventer on the forged version is integrated and built inside the valve. And if you see on the picture on the left, we have a drill line going through the guide, and then through the disc holder on top of the disc. The disc is not connected to the disc holder like a normal valves that you've seen in the past. The pressure comes in, the pressure pushes the disc down through that hole, and the disc stays in place even though the piston is moved up. So it's no pressure. Whichever side sees the highest pressure first, that's the side that's going to load the dome. So if you're starting up and all these other discharge pressures coming in from the superimposed locations exceed the inlet pressure, then the dome will automatically be loaded, or disc will be held tight and keep the valve from lifting. So we never change the ratio between the piston stroke and the disc diameter. They're both optimized. So this new solution improves the main valve integrity. It helps reduce the leakage and defects. And at the same time, it optimizes the global response time in the process. So that's the unique feature of the backflow preventer. So now we wanted to make the valve highly modular. So how will we do this without adding more piping or something else to the valve? Well, if you look at, there's 5 blocks here you're looking at in the screen. The first block is connected to the pilot as you see it already. This pilot has no accessories. Well, if you want to remote sense it, then you just take that block off and add this block where you can remote sense it. If you notice on the screen where the little arrow dot is, that's where you would hook your feed line through that hole right there. Well, I want a filter on it. That's where the third block comes in. There you see the filter built in. So the process will be filtered before it gets into the pilot valve. So, well, what if I want a remote sense and a filter? Well, there's the fourth block. It's all built in. And of course, if you want a field test connection, then the last block. The last block has every accessory that's available, and it's just bolted on. So it couldn't get any more modular than that. So let's summarize what we've seen today, okay? You had customer needs. You wanted no leaks, no defects, and very high performance. So our features and benefits, as you've seen in the presentation, was you had a forged housing design. We optimized our DCS pilot with a high pressure version. We use pressure feed throughs and wedge locking technology, and we offer the nose tubing solution. So what does that mean to you as a customer? Number one, we brought the valve cost down 60% from a casted version. Number two, no defects, very modular. So we have the modularity. And the insurance cost, it's less, it's 0.1% of what it will cost you to operate these valves. And the value is $15 million. Oh, excuse me, $1 million plus, I'm sorry. So that's why you can see why the forged block solution would fit in the FPSO market today.
Yeah, the 1 million plus corresponds to the fact if you have some failure on more than 20 plus the valve, casted valve in your installation.
Right.
So what I mean before, the price increase significantly. So thank you, Billy. It's quite clear, and we hope you enjoy this presentation. And now we are open for the Q&A session. If you have any question, let me have a look. Take a look.
Go back to the question.
Yes, I have a question from Marvin Mann. Please confirm the modulating action is not a constant bleed, balancing vent only. Are you referring this for North Sea application? Or what does CO2 to the operation? There is many questions here. There is 3 questions, I think. So the first is regarding the modulating action. Constant bleed. I'm not understand what means bleed.
That means it's bending the whole time. The modulating pilot only opens in proportion to the overpressure.
I mean, it's flowing on that case. Flowing?
Yeah.
Does it mean flowing? So no, our pilot is a non-flowing pilot. it is flowing when you have to vent the dome. So that's the reason there is a yellow line. But because in the introduction we show there is a yellow line, and the reason is you connect the pressure localized into the dome, you vent the dome pressure directly to the body bore. But it's considered as a non-flowing pilot because the pilot is not leaking when it is in a stable position, and it occurs most of the time. So it is just the few quantity of leakage localized into the dome that has to be vented. Are you referring this for North Sea application? When you see North Sea, I think about some NACE requirement, such kind of thing. So yes, this pilot comply with NACE requirement. For example, if we work for source service application, that's the reason we have again the yellow line, because there is no leak outside, and the fluid is still contained in the pressure containing part. So the pressure vessel, what we call the pressure containing part. Indeed. So yes, we also offer such kind of pilot for North Sea application. We have some project into North Sea, and we already deliver a forge block for a project in localized in North Sea, of course. What does CO2? Good, perfect. Freezing condition. So we have two kind of pilot. But it's regarding the main valve. So into the main valve, we have the 76 series, what we call the full nozzle type, and the 78 series, what we call the semi-nozzle type. And both of them work on cryogenic condition. I mean, normally we prefer to go with full nozzle because you don't have any gasket, and it operates on a real cryogenic condition. And at the moment, the engineering developed test 78 series semi-nozzle type with PTFE gasket to comply with cryogenic requirements. This upgrade has been performed to stick to our competition, especially in US. So from the beginning, we do insist. I would say the full nozzle was preferred, but we also demonstrate good performance for the semi-nozzle. But in the strategy, we prefer to go with the full nozzle. So this is only for the main valve. So now regarding the pilot selection, we protect the pilots because for freezing condition, keep in mind, the only issue is regarding the gasket selection. And valve is not supposed to operate for a long time. So that means even as soon as you have a dead vent, the pilot operated valve won't never see cryogenic condition. You have to make the valve discharge for a long time to work on a cryogenic condition. And we protect the pilot with what we call cooling coil or a buffer tank. It's not really a cooling coil, but it's a warning coil in that case, but it's a buffer tank that helps the fluid to warm up before arriving on the pilot. So yes, just to summarize, because maybe I'm a little bit too much technical here, but the valve work in cryogenic condition. We also have a significant project and significant reference in the LNG industry, where the valve operates on very cold condition. When I said cold condition, it's the process, but also the environment, because without, I cannot mention the project, but as you can imagine, our products are also localized in the extreme north, in Arctic, without mentioning the project. All right. You're welcome, Marlene. I don't see additional.
There's two in the block, in the question answer block.
There is two additional questions?
Yes.
Yes, sorry. Let me check that. So, second question. regarding the special design of this forge block PSV, in case of failure of the PO-PRV on the FPSO, do you have a service department and engineering able to intervene quickly on this side of PO-SRV with required tools and spare parts? So yes, it is a part of our strategy. We have a service center in US, and we developed this in France as well, that can operate 24/7 time. I think it's the correct language.
Yeah,
so we can provide dedicated support. All over the world, except a country where we cannot operate due to some sanction, I would say. But in any case, if there is some sanction, we don't sell the product. So anywhere in the world where our product is in place, we warranty a service, of course. What we are doing, especially for ASME 1, because for ASME 1 service, it's a separate topic, but our service activity is mainly for this kind of valve, because service is required when you start the valve into the plant. For FPSO condition, we need a special accreditation to go on site, but if customer accepts, we can support, of course. And we also work with a repair center all over the world. What's the maximum pressure label for this type of pilots? So it's a 10,000. It's a 10,000 psi. The inlet flange has been developed in 14,000 psi. However, it's the maximum pressure here. It's 10,000 psi because it was as per customer requirement. We can reach higher pressure if required. But the most important is not only the pressure. You need to consider both parameters. You need to consider the pressure and the section, because at the end of the day, it's the maximum allowable stress into the material you have to consider. So what is interesting here is we develop a big, significant size at a very high pressure. And this everybody is not able to do. So what's the difference between PSV, TRV, and PRV? That's a good question. Some people can be concerned.
I can answer that, Sebastian.
Yes.
Please. PSV, process safety valve, is often that is what's used in the plant to identify a certain PSV. That's the PSV number. It can be PSV A, B, or C. So that's the number that they use to identify the valve and its location in the unit itself. PRV is what we call a process relief valve. So that's what we use in the market when a valve is not installed. So it doesn't have a PRV is a relief valve, plain and simple. It could be a flange type, it could be a screw type, but it's a PRV. Now the TRV kind of got me puzzled. I do not understand what TRV. I'm not familiar with that in the marketplace. Did they hear me?
Yes.
Okay.
Yes. I catch you.
All right.
Thanks, Billy. Of course, the webinar is recorded, and you can, if you miss some information, you can take a look on our webpage, YouTube, on our YouTube page. So you can take a look again. I have some questions into the Q&A box and some questions in the discussion. What is the lowest set point gas service? As per ASME, the lowest set point is regarding the ASME requirement. It's two separate topics here, because this valve is able to operate at a very high pressure, and it is not a customer target to reach the lowest set pressure. I would say the set pressure is a money maker, but not the set pressure, but the operating pressure is a money maker. That means the highest operating you can have, the highest profit you can expect. But due to the valve technology, if you go either on spring or pilot, you have to reduce the operating pressure. Just to give you a rough idea, but for spring loaded, the maximum expected operating pressure is 90% of the set point. But for pilot operated pressure, you can expect 100% for the main valve, 98% for the pilot. So the main valve will be tight, but the pilot will start to leak. So you increase significantly the operating pressure and you make profit. So now to reply to your question, there is overproduct type. It's a tank storage protection, so very low pressure. But when I said low pressure, it's something like 15 millibar. So it means less, it's 1 psi, something like that. But if you follow Billy's instruction, ASME is a low and it is applicable from 15 psi. Under this value, the valve has not to be stamped. So for this kind of product, I would say the lowest set point is as per ASME. It's a 15 psi. But if the valve operates in 15 psi, on that case, you don't need to develop such kind of forge block solution. It's not the same parameter. And this valve can operate on both gas, liquid, two-phase mixed media. So and also it could work on steam. We would have to put in place some buffer tank, but basically we cover all kind of media with that. So what about steam section 8? If you look at the red book, you will see for any product you have two kinds of certificates. The first certificate is for air and steam, and the second for the liquid. So any product is certified for both. I would say gas and steam, because steam is included in the gas certificate, and liquid certificate separately. But the valve operates on steam service with the same directed flow coefficient as per ASME section 8. So that was into the discussion. Hope I answer the question. You're welcome, Marvin. And so in the Q&A box, what's the maximum pressure level for the type of pilot? On that case, it's a 10,000 psi for this pilot, but it's a very high pressure pilot. It's a special pilot. But regarding the pilot, as you can see, finally, the section area is really reduced. When you reduce the section area, the stress is very low. So definitely, I answer the question, but in this, you have two separate products. You have the main valve and the pilot. Into the main valve, you have a significant section area. Into the pilot, you have a very reduced section area. So my question would be, do you think the pilot is really limited? And the answer is no. The pilot can withstand higher pressure compared to the main valve. The limit is from the main valve because the section area is bigger. So the pilot, we fix the pilot limit at 10,000 psi, but basically this pilot can withstand up to 20,000 psi. It's not an issue because the drain spindle section is reduced, and because there is no section, there is no stress. No stress, you can increase the pressure significantly. It's the main difference between pilot-operated version and spring-loaded version, because in the spring-loaded, the spring size is significant, and you have, as soon as you change the set pressure, you need to change the spring. But for pilot-operated version, for casted version, just to give you a rough idea, we can cover the complete pressure range with only 3 springs into the pilot, because any spring, due to the low stress, can cover a very large pressure range. So on that case, the pilot is not really limited. You can reach a very high pressure, 20,000 minimum. Okay, I don't see additional question. I think I hope we answer your question. Thank you for your interest. It was very interesting to have such kind of Q&A session at the end of the session. Okay, you're welcome. Thank you for your attention. And as a reminder, if you miss some information, it will be available into our YouTube page.